Or C, saving plans and investments. In this section, we'll be talking about something called annuity. Annuity is a sequence of payments. So what happens is instead of putting in $2,000 and just leaving the $2,000 for 5 years, and during those 5 years, we never add any money to it, we're going to do something different. We're going to say, we're going to try to save up $2,000 every year. We're going to put $2,000 at the end of the first year, $2,000 at the end of the second year, $2,000 at the end of the third year, fourth year, fifth year. And we do this in real life when we are trying to save up for, say, a big event like a wedding, a trip. It can be saving up money for retirement, or it can be the other way around where we are paying back money, and we are paying back, say, a mortgage loan, like for our houses or for our car. And what we are going to be doing here is a little bit different from compound interest. In compound interest, we have one amount, and that amount will grow for a certain time period. Here, we actually put in 5 different amounts. And each of these amount, like the $2,000 that we put in at the end of the first year, will be able to grow 4 years. And then the $2,000 at the end of the second year will be able to grow 3 years, then 2 years, 1 year, and the last one doesn't grow at all. What we have to do is add everything up. If you have taken a different math class before and learned about geometric series, this is how we are going to be adding these up. For the purpose of our class, we're going to give you the results right away. You will be provided with this formula on the exam, but you have to know what A represent, what PMT represent, what APR represent, etc. You have to know what the symbol represents. And you'll notice that this formula here is quite complicated, and it will take some skill and some familiarity with your calculator to be able to come up and calculate the correct answer. Let's try an example together. Let's say that we are that we put in $2,000 into a saving plan at the end of each year, and our rate is 3%. How much will we have after 5 years? We're going to use our formula over here. The payment, the amount that we put in, is $2,000. So this first part is 2,000. The APR is 3%, but remember, whether it was the section before in 4B in compound interest or this section in 4C, whenever we use the rate, whenever we talk about the rate in percentages, when we do the calculation, we have to change the percentage into the decimal form. We will divide the 3 by 100 to get to 0.03. Interest is paid once a year, in this case, compounded annually. So n is equal to 1. Let's put all these numbers into our formula. You'll see whenever we have APR, we put in 0.03. Whenever we have n, we put in 1. And we have n times y. If you're not familiar with your calculator, the easiest thing to do is to do each of the smaller brackets separately from one another. If you do that, you should be able to find that here we have 1.03, here we have power of 5, and here we have 0.03. Next, you should still know that there's a notice that there's still the square brackets at the top in the numerator here. Next, after you do all that, you can put everything into your calculator all at once. And whenever you do that, just remember to put in the brackets. That will help. So 2,000, and what we're going to do is we're going to multiply by, and here we will need the bracket. Okay, so it's important to write down the brackets like the way it's given in the question and do in the formula, and try to solve each of the brackets separately. If you try to put more than just the bracket in, like in this case, we're doing 2,000 multiplying by the bracket, you will have to put the bracket in yourself in the calculator. Here we're doing to the power of 5 minus 1, close the bracket, and we want to divide it by 0.03. And you'll notice that in this case, we get 10,618.27. Now, if you're not sure, you can always double check. You can always estimate really quickly. We put $2,000 in every year. We do this for 5 years. So 5 times 2,000 is 10,000. Right? 5 times 2 is 10, so 10,000. And we have a little bit more than 10,000 because we got all that interest. So our number makes sense with our estimation. Let's do something slightly different. Here in Canada, we have something called the tax-free savings account. And the tax-free savings account allows you to save up money, and the government promises you that anything that you have inside, whenever you get interest or whenever you get growth, you're not going to be taxed again. And this is designed to encourage you to save up for future retirement. Right now, you can fill your tax-free savings account once you become a Canadian, really simply with $500, $600 a month. And let's say we are able to grow our money compounded monthly. Usually the compounding period using our formula is the same as the compounding as the period that as the payment period that we put in our deposits. So here we put in $500 every month. We're going to do our compounding every month as well. Here the rate is 4%. We want to know how much you will have after 30 years. We're going to use the same formula. We're going to put the numbers in where they belong to. And remember, if you're not very good with your calculator, don't try to put everything in all at once. Try to put in the value in each of the small braces and try to calculate them separately. Now, if the number doesn't round very nicely, please keep a few more decimal places. And just remember in this case, in this particular example, we still have the square brackets. That's in the numerator here. And so when you put everything in your calculator, if you try to do that all at once, instead of doing the numerator separately, you can do that part separately. But if you don't, remember to put brackets in your calculator. So that will give you $347,025, roughly. There's a different way to do these calculations. If you're working with accounting or working in finance, they typically have some sort of spreadsheet that you can use. So you can turn on like a Microsoft Excel or a Google spreadsheet or a Google Sheet. In Microsoft Excel, what you can do is you can simply put in the formula that's pre-designed for you, and we use FV as to represent future value, how much money we'll have in the future. And usually in Excel or in Google Sheets, there's sort of hints to tell you what you have to put down. Here, in the example that we did with the tax-free savings account, the interest rate is 4%. Now, because we are compounding monthly, we have to divide it by 12. Now, you can write 4% divided by 12 in these spreadsheets, or you can do 0.04 divided by 12. Both are acceptable in the spreadsheet. The number of payments, the number of deposits that we put in is 12 months times 30 years. And each month we put in 500. And that's all we have to put in. And you'll notice that in this case, it gives us the answer right away. So you can do that you can use this to double check your calculation really quickly when you're doing your assignment and practice questions. Now the number is negative because in accounting, they need to track the positive and negative for different purposes. We're not going to go into details with that. So these type of calculation allow us to plan ahead for the future. Suppose you want to get $1 million in order to retire in 20 years, and you want to put in payments every month, and we can calculate how much payment that is. We're going to use the same formula, and this time we're going to use the formula a little bit differently. And it's going to be a little bit different because we don't know what the payment is, and we need to find the payment. But we do know that at the end, we want $1 million. Everything else is roughly the same as what we have been doing. APR 6%, we change that to decimal form 0.06. We are doing this monthly, so N is 12, and then we are trying to do the accumulation over 20 years, so Y is 20. Once again, to solve this, solve each of the bracket first. That makes things easier to do. And then here we have a little bit of a number on the right-hand side. So if you want, you can actually find out what this whole number is. We can find out what that whole number is. We put it into our calculator, and it's 462.0409. Once I do that, I will be able to find the payment by itself. And what I need to do is I need to divide both sides by this 462.049. So we're going to divide it by that on both sides. And that will give us our payment. And in this case, $1 million divided by 462.0409 is about 2,164. So if you're able to save up $2,000, a little bit more than $2,000, and you can grow the money at 6% every year, in 20 years you'll have $1 million, and you'll be able to have a big pot of money that will support you through retirement. In finance or in accounting, the spreadsheets also allow us to do the payment calculation really quickly. The way we do it is really similar, and this time we will use the payment function. In the example that we did previously, we have 6%, and we are compounded monthly, so we divide it by 12. We are trying to grow our money 20 years, so 12 months a year times 20 years in total. The present value, so PV here stands for present value. That means how much we have at the start. We have zero, we have no money at the start, so zero. And we want to save up, and we want to save up $1 million at the end, and that's the final amount. And you'll see that we get $2,164. When we plan for retirement, what you have to do is you have to estimate how much you are going to spend every month. So when you imagine you're retiring and you don't want to work anymore, how much money do you need? Perhaps you need $3,000. You can have a different answer here, and you'll just use a different answer to do the calculation. Now, if it's $3,000 every month, you also need to find out how much can you grow your money after adjusting for inflation. Let's suppose we can grow our money with 4%. So that means whatever pot of money I have saved up, I am able to get 4% every year, and I can divide it by 12 to find out how much I get every month. If you need $3,000, that number needs to be 3,000, right? Whatever the amount of money you have every month at 4% will give me $3,000. And that's the way we do our calculation to find out how much money we need to provide us with $3,000 every month forever. Now, in this case, it's actually not a lot of money. It's only $900,000. If you have $900,000 saved up, instead of buying a house or an apartment in Vancouver, you will be able to invest and get $3,000 worth of income every month. And that's a pretty good deal. Now, when you're planning on retirement, then you have to think, okay, how many more years do I have to work? If I want to work 20 years, I can grow my money 4%, and 900,000 is the money magic number that I need. We will use the calculation that we did in the last example. Here, we're just going to show you the result using the spreadsheet. And the result says, oh, we had to save up $2,500 or $2,400.53. And that's not too bad, right? If you think about saving up $2,500, if you can do this every month for 20 years, you can stop working. And if you stop working, or you can keep on working, it doesn't matter. But the pot of money that you have at the end, the $900,000, is able to provide you with an income of $3,000 every month. And that's what we do when we do retirement planning, to figure out how much money you need, how much money you're willing to spend, and then how much we have to save up. As you notice so far, it's important to know how fast or what's the percentage that I can grow my investment, right? Before we are doing our calculation and we're throwing out percentages like 3%, 4%, and 6%. But how much can you grow your investment? Because hopefully you'll learn more than just putting money in a bank account and get interest, right? Perhaps you learn how to invest in bonds, lend out money to government and companies. Perhaps you learn how to invest in stocks, how to become sort of like a shareholder of a business. When we calculate return, when we calculate how much our money is growing, there are two different types of returns we can calculate. One is the total return. The total return tells us how much more did the money grow in total. But most of the time, we're not that interested in the total return. Most of the time, we're more interested in the annual return. That's the annual percentage yield. That's the amount we can get every year, the growth that we can get every year. And this is a formula. And we'll be providing you with this formula on the exam as well. So suppose we invest $1,000 in a fund, in an exchange traded fund. Exchange traded fund are ones that's sold like a stock, but so it's easier to purchase. And let's say we invest in a fund like this, and the fund grow from $1,000 to $1,400 in 7 years. To find the total return, we simply find the difference, subtract the two values. We found that we made $400 more, right? We made $400 more. $400 compared to the $1,000 that we start with is 40%, 0.4 or 40%. So you'll notice over here, when I take 400 divided by 1,000, you'll get 0.4. And this part over here is just reminding you that we're changing the 0.4 into decimal, percentage form. We multiply by 100. To find the annual return, we simply divide the two numbers, 1,400 divided by 1,000. And here we need to do a fraction. We need to do a fraction of the exponent. And notice how we have all these brackets here. The brackets here are important. So if you want, you can do each of these brackets separately. You can do 1,400 divided by 1,000 and get 1.4. And you can do 1 divided by 7 separately, and you'll get a decimal number. Here, I chose to do everything all together. But you can do it in a different way. And in fact, I recommend doing it this way and find that the top over here in the exponent, that's the exponent over here, that's 0.14285. So when I do my calculation, 1,400 divided by 1,000, divided by 1,000, I do that first. I get 1.4, and what we will do is we'll do 1.4 to the power of 0.142857. So I do that, 0.142857. I'll just type everything in. Doesn't really matter. So this is a number that we have, and we have to subtract it by 1. And we subtract it by 1 to subtract the original number that we start with, right? Remember the 100% that we start with. We end up with 0.049. And just remember to convert that into percentage form. This part over here always reminds us to convert into percentage form. And we do that by multiplying by our number by 100. So this gives me 4.92. So we got 40% in total, but 40.92% every year. One last thing to show you, last section we talk about bonds. This section will talk a little bit about stock. Now, stock are companies that decided to be sold in their individual parts called shares. And what you'll be able to do is you'll be able to purchase a small piece of the company, a small share of the company. Each share will have a certain price. When you look up information of a stock like Microsoft or McDonald's or any of the big banks that's in our country, or the big telecommunication, your cell phone provider, they are usually public companies that you'll be able to buy a little piece of. Now, there's a lot of information in here. We are only going to introduce one in our class today. We're going to introduce something called the price to earning ratio. And the earnings is one of the very important ways for us to decide whether a stock, whether a company is a good company or not. A good company, we will only want to be an owner of a company that is making money, right? We want to be, if we own a company, we want it to be making money. We don't want to be owning a money that's losing money, and eventually we lost all our money. The price to earning ratio tells us how much we have to pay for that earning. So for example, if I'm trying to sell you a restaurant and I'm telling you, oh, my restaurant make $1,000 every year. So that's the earning. And I want to sell you this restaurant for $3,000. And that's the price, right? How much I want to sell it to you. We will have a PE ratio of 3 in this example. And if you think about what 3 means, if you think about it in terms of simple interest, you pay $3,000, you will make $1,000 every year. It takes you 3 years to make back your money. Right? You get $1,000 one year, $1,000 the second year, $1,000 the third year, 3 years to make back the 3,000. PE ratio tell us how many years do you need to make back your money in simple interest terms. We're not thinking about compound interest. We're just in simple interest terms. And of course, if I try to sell you my restaurant with a price of $5,000 when it's making $1,000 a month, then the PE ratio would be 5. That means it's a more expensive price, right? I'm selling you at a price of 5,000 instead of 3,000. So the PE ratio goes up. The higher the price to earning ratio, right? If you think about it, it's the price, right? The higher the ratio goes, the higher the price you are paid. Let's look at an example. Enbridge is one of the biggest oil and gas company in Canada. Chances are, if you know someone driving a truck in Alberta driving oil around, they might have heard or worked for Enbridge at some point in their life. A few years ago, Enbridge's stock market quote will look like this. The big number up top is the price for one share. If you want to buy one small piece of Enbridge, it will cost you $42.05. The earning every year, the past 12 months, it made 98 cents. So what's the price to earning ratio? The price is 42.05. The earning is 0.98. So the price to earning ratio is almost 43. Is this an expensive company or is this a cheap company? Well, it turned out for most of the company in the United States stock market in the S&P 500, the average price to earning ratio goes up and down, but it's usually somewhere between 15 to 20. So it takes us 15, 20 years to make back our money. A price to earning ratio of 42.9143 is on the very high end. It makes this company very expensive.